In this video, you will learn how to integrate functions using integration by parts. By the way, this is the second part of the integration by parts lesson. Right. What is the integral of 2x plus 1 times secant x tangent x dx? Now, to solve this using integration by parts, we let u be equal to 2x plus 1. Then we get the derivative of u du. So this is just 2 dx. Then our dv would be secant x tangent x dx. Then the integral of this. So we have v equals integral of secant x tangent x dx is just secant x. And now we can employ or use the integration by parts formula. So that would be uv minus the integral of v du. So u is 2x plus 1 times v, which is secant x, minus the integral of v, which is secant x. Du is 2 dx. Right, and then we have 2x plus 1 secant x minus, all right, we factor out 2. We put 2 outside of this one since it is a constant. Then the integral of secant x dx is just ln of secant x plus tangent x, then plus c. Therefore, the integral of 2x plus 1 times secant x tangent x dx is just equal to 2x plus 1 times secant x minus 2 ln of secant x plus tangent x plus c. Now let's solve another problem. Alright, solve for the integral of x secant squared x dx. Alright, we let u here. Let u equals x. Because x is algebraic, we use the LIATE. I'm sorry, I forgot to mention the LIATE in the previous problem. So we choose the algebraic first in choosing for u. Then du here is dx. Then dv is secant squared x dx. Then we integrate this to solve for v. Therefore, v is just equal to tangent x. Because the integral of secant squared x dx is just tangent x. Now we can plug in everything into the integration by parts formula. That is uv minus integral of v du. So u is x times v, that is tangent x, minus the integral of v, which is tangent x. Du is dx. And now this would become x tangent x minus, okay, the integral of tangent x is just ln of secant x. So this is just minus ln of secant x plus c. Therefore, the integral of x secant squared x dx is just equal to x tangent x minus ln of secant x plus c. Now solve for the integral of ln of x dx. So we only have one function here, ln of x. So we can let u be equal to ln of x. Then derivative of u is just 1 over x dx. Then our dv is equal to dx. We integrate this, then v is equal to x. Then we plug in everything into the integration by parts formula. So that would be uv minus integral of v du. U is ln of x times v, which is x, minus the integral of v, which is x, and du is 1 over x dx. So that is dx over x. Right, and this one cancels out. So we have x ln of x minus the integral of dx, and this is just x ln of x minus the integral of dx is x plus c. Therefore, the integral of ln of x dx is just equal to x ln of x minus x plus c. All right, now we have, we need to integrate x ln of x dx. So in this case, we let u be equal to ln of x. So we choose logarithmic first before the algebraic or polynomial. Then du, derivative of ln of x, is 1 over x dx. Then dv here is just dv is x dx. Then we integrate to solve for v. V is just equal to x squared over 2 dx. Now we plug in everything to the integration by parts formula. So that is uv minus integral of v du. U is ln of x times v, which is x squared over 2. Oh, sorry about this. You don't need to put dx here, because we've already integrated this. All right. Minus integral of v, which is x squared over 2. Du is 1 over x dx, or dx over x. Then this cancels out, x squared and x. We'll be left with x here, 1, x to the 1. Then we have 1/2 x squared ln of x minus, all right, we factor out 1/2. We put 1/2 outside because that one is a constant. Then we have integral of x dx. And this would become 1/2 x squared ln of x minus 1/2 integral of x is x squared over 2 plus c. So our final answer would be, what's this? 1/2 x squared ln of x minus 1/4 x squared plus c. Therefore, the integral of x ln of x dx is just equal to 1/2 x squared ln of x minus 1/4 x squared plus c.